Hi class, let's do some conclusion of this chapter, and after this lesson, there are just 2 chapters to go. In this chart, I used the red color to point out every common use intervals. In this chart, P represent perfect and lowercase m represent minor, and the capital M represent major, and A represent augmented, where D represent diminished. So for all the red color intervals in this chart, from the left to the right and from the top to the bottom, each interval is one semitone more than the earlier one. For example, the minor second is one semitone more than the unison, and major second is one semitone more than the minor second. Minor third is one semitone more than the major second, and the major third is one semitone more than the minor third. So this list is just going on, except the augmented fourth and diminished fifth are exactly the same size. They just have different names. So, except those 2 intervals, each interval has one semitone more than the earlier one. So that in this chart, you can have an overall conception of how interval works and the size of different intervals and the relationship between them. And also, if you ever want to check which interval contains how many semitones, you can always refer to this chart. I will also upload it to the Canvas, so you can always check it when you're confusing with whatever size of intervals. In the previous lessons, we used consonant and dissonant to describe different features of different intervals. Consonant means the notes are blended very, very well, and it sounds pretty pure, pretty stable, so that composers use consonant intervals at points of arrival or conclusion. For example, at the beginning part of the piece, you may want to choose some consonant intervals, and also at the ending part of the piece, you may also want to choose some consonant intervals as the harmony or used on your melody. And dissonant for me, it means like more anxious, more nervous, more some negative emotions. So it sounds relatively tense and unstable, with the notes rubbing against each other rather than blending together. So, if you feel like I don't want to use consonant or dissonant to describe different features of intervals, you can always choose your own way to describe different intervals, like how you feel about these intervals. For example, if you want to use, I feel like the major second is nervous, and I feel like the minor third is sad, and I feel like the major seventh is anxious. You can always choose different descriptions and different words for different intervals. So consonant and dissonant is just a very conventional and very typical way for the teachers and for the instructors to tell their students how that different interval feels. So what I want to tell you is those 2 words are just for reference. You can totally have different feelings towards different intervals. So those several intervals belong to consonant category, and those several intervals belong to the classification of dissonant. So that when you are writing a piece, knowing which intervals are consonant and which intervals are dissonant really helps. And either choose consonant intervals or dissonant intervals really depends on what you want and what you are feel comfortable with the emotion you want to express in your piece. Just like we've learned in the rhythm chapter, there is simple meter and compound meter. In intervals, there are also simple intervals and compound intervals. What we've learned in the previous 3 lessons are all simple intervals. What simple intervals means is that intervals smaller than an octave are called simple intervals. We know that an octave is a perfect eighth. So from unison to major seventh are all simple intervals because they are all smaller than the perfect eighth, aka an octave. But interval larger than an octave are called compound intervals because they consist of simple intervals plus one or more octaves. Let's take this major second as an example. Here is, if we use treble clef, here's C and here's D, so that is major second, right? And if we want to add an octave to this major second, then we got a major ninth. Why it is ninth? Because 2 plus 8, it should be 10, right? But why it is ninth? So remember that we always need to minus 1 from the total number of those two intervals. Why? Because this C has been counted twice. The first time it is counted from this C to this C, so it is an eighth. And the second time from here to here, it is a second. So this note has been counted twice. That's why we need to minus 1. So we got a major ninth. And here you may have another question because you know that we use major second plus perfect eighth, but why we got a major ninth rather than perfect ninth? So always remember, because compound meter is the combination of a simple interval plus one or more octaves, and the quality of the interval, the quality of the compound interval has always followed the simple interval's quality. So for this example, because the simple interval's quality is major, so that's why the compound interval's quality has also to be major rather than perfect, because you cannot follow the octave's quality. Okay, I know this is a little bit confusing. I will be sure to explain it one more time in the meeting. And how to call the compound meters. Compound intervals are referred to either by their simple interval names or by the total number of the steps they contain. So for this example, you can either call it just major second or you can just call it major ninth. I recommend to just use the simple interval name to count the compound meter because this way is much easier. So the question here is, if you've got a compound interval, how do you calculate the quality and the size of these compound intervals? So let's take an example. Look at here. Let's use treble clef. Ignore those two. If one note is here and another note is here, if you recognize this interval is larger than an octave, then the first step is, you know, this is compound interval, right? Then the second step is how to calculate the quality and the size of the compound intervals. So the trick is you can move either the bottom number up an octave or you can move the top number. So if you choose to move this bottom number up an octave, then it's going to be here because these two are both C. Then you just simply calculate the size and quality between these two notes so that you got a perfect fifth. Then the perfect fifth is the name of both the simple intervals and the compound interval. And another way is you can choose to move the top number lower an octave. So we got these two notes because this is G and we lower it an octave, we got another G. So just simply calculate the size between those two notes. It is also perfect for it. So either way works. I'm going to write it down here. The first way is you can move the bottom note up an octave. Or the second way is you can move the top note lower an octave. Okay, here let's take more examples. For example, I want you to calculate the size between this. So the first step is you're going to recognize if this is compound meter or not, if it is larger than an octave or not. So for this, it is a compound meter because it is larger than an octave. And the second step is you can either choose move the bottom number up an octave or move the top number lower an octave. So if you choose this way, it is going to be F sharp and A. If you choose this way, it's gonna be F sharp and A. Either way, you got a minor third. And because scales contains a lot of notes, so that there are a lot of intervals in the keys and in the scales, any notes in any key can build as intervals with any other notes in the key. So because there is a fixed pattern for any major and there's a fixed pattern for any minor, so that the interval between any given scale degrees are the fixed. For example, for any major key from scale degree first to, let's say, scale degree 6 are always major 6. And for another example, for any minor keys from scale degree first to scale degree fourth are always perfect fourth. Of course, you don't need to memorize it. You just have to know how to calculate intervals by using either semitones or whatever way you choose. So the only thing I want to point it out here is about harmonic minors, because we know that from scale degree 6 to scale degree 7 in the harmonic minors is augmented second. So that is the special feature for harmonic minors. So of course, the inversion of augmented second is diminished seventh. So from scale degree 7 to scale degree 6, for example, for A minor is from G sharp to F is a diminished seventh. So just remember those two very special intervals in harmonic minors.